This is Dr.Aravind Rajan. I am actually an associate professor at the Department of Aeronautical Engineering here at IARE. And today we will actually be seeing about aircraft systems. So aircraft systems are actually a type of, I can also say that they are a group of subsystems which ensure flight safety and safe operation of any aircraft, any given aircraft. These are also applicable for civil as well as military aircraft. So first of all, we'll be seeing here what are the concepts of systems and what are the subsystems, and the generic system definitions such as what are the inputs and outputs for any given system, and what is a feedback, and are there any external influences for an aircraft system, and if so, how do they influence? Okay. And afterwards we'll also be seeing what are aircraft systems, where we have airborne systems such as airframe systems and vehicle systems, which include landing gears or even the airframe such as the cabin, inner cabin, and everything. Also the avionics systems. Avionics is nothing but the electronics that we use in aircraft is known as avionics systems. And the mission systems. Mission systems are actually navigation systems or even flight control systems, which ensure, as I said earlier, which ensure a safe operation of an aircraft. And from a design perspective, we'll be requiring to see what are the specifications of requirement. For example, if I am a designer and someone is asking me to design a civil aircraft for a certain capacity and this kind of mission requirement. So first of all, before getting into the drawing board, what I do is I write down my mission requirements and my performance requirements. I need this much range, I need this much altitude, and so on, which you'll be seeing also a part in conceptual design of aircrafts. So based on similar kind of design, mission requirements and performance requirements are actually required for designing any aircraft system. Okay. So let us see what are system concepts. First of all, I'd like to know what is an aircraft. So aircraft is nothing but a vehicle which flies through lift from air. For example, let us take a bird. A bird, how does it fly? It flaps its wing, it generates its lift, and there is a difference between pressure from between the lower and upper surface of the wing. A similar kind of system, lift mechanism is available. Is behind the flight of aircraft. So this system mechanism is known as aerodynamic lift. We also have other kind of lifts known as buoyant lifts, where we fill up some balloons or any given container with a gas. For example, let's say hydrogen or helium, and it flies till the atmospheric level where it has the equal density. So that is buoyant lift. But here we will be seeing aircraft. Aircraft is nothing but a vehicle which generates lifts through aerodynamic lifts, and it flies through lift from air. This actually originates from Greek, the Greek language. So when you see the aircraft systems, we have different systems where we see airborne aircraft systems such as the airframe. We have the vehicle systems, avionics systems, and mission systems. But do remember, an aircraft system or any subsystem are the one which ensure a safe operation of a flight. Okay, so having said that, we have already encountered the words system and subsystem, but what are they? So you don't get perplexed. We just say it. An example of any aircraft system. For example, if you see here, you have the engine and you have fuel. Fuel, where do we? Most of the aircrafts today, the 21st century aircraft store their fuel in wings, which is known as wet wing or dry wing, where you have other kind of inner structural components where you can store fuel. That is not important for us right now, but we have fuel systems. And you can also see that there are different color coding in this figure. So one which have orange color is nothing but it's fan and cabin air. So what happens is we have a fan casing. That means from the engine we actually suck some air, which is cooler because at high altitudes the temperature is less. So which is cooler and which gets into the air filter. Once it gets into the air filter, we'll send it actually to air conditioning unit, and based on the requirement, we'll be having either conditioned, air at less temperature, or cool air, or at a high temperature as per our requirements. And on the other side, we have the fuel systems, which is indicated in purple or violet color. So these are nothing but actually different systems which are working together. Okay, so they might be subsystem of another systems, but they are working together to ensure good operation of an aircraft. Okay, so when we go further, as I said, we have already encountered the names system and subsystem. Okay, any system, take any system like aircraft wing system or airframe system, for example, it can be broken down into different subsystems. So as we can see in the figure over here, we have system, for example, an aircraft, which is broken into different subsystems, and where we have airborne systems like this one is airframe systems, and second system we have avionic systems, third system we have mission flight systems, and each, for example, the first subsystem, which is airframe system, is actually divided into another sublevel where we have wing, fuselage, and cockpit, the empennage, different kind of systems. So what I'm saying is a major system, any system, it can be divided into further subsystems, and each subsystem can be divided into further subsystems at an infinite number of levels. But we cannot use, it is best to be avoided to use infinite number of subsystems, because once we get into it, the subsystem which we will be using might have some other subsystems, but it might be part as a system, a major system. So we should avoid using more subsystems just to ensure good operation or getting confused during production or maintenance issues. Okay. So as I say here, a total system is a system of systems. The definition you can see over here. The total system, that means an aircraft is actually a system. Let us take an everyday example. So you'll be using computers. Okay. When I say a computer, which is nothing but a processor. But whereas we have different things which are used in daily life with a computer, the monitor, keyboard, and mouse, and we also have the CPU, which is the main where we use all the calculations and everything. So in the CPU, we have motherboard. Motherboard consists of RAM, the graphic cards, and other visual cards, electronics, which ensure a well and good operation of a system. So a computer is a system. Similarly, an aircraft is also a system. A system which can be broken down into major subsystems, where at each major subsystem can be broken down into a lower level subsystem. So if you see this figure over here, what you're getting is, it is a hierarchical level of subsystems. We have a major subsystem which is broken into first level, and then we have second level of subsystems. Each subsystem, each second level will be having third level of subsystems. Any organization will also have the same kind of hierarchical levels. So an example, for example, I've said a hierarchical level of subsystems. Let us see the first one. Here I have given three different color codings. A, which is in blue, and B, which is in green, and we have C, which is in red. Okay, and these actually can be incorporated into an aircraft design. When you're designing an aircraft, you'll not only design an aircraft, you'll also be looking into possibilities that you will be foreseeing during manufacturing. So that is one perspective when you're doing conceptual design, not a conceptual design, when you are designing any aircraft. So for example, here, let us say that you have an aircraft which has the individual systems. So level 1, major subsystems. Okay, those are nothing but individual systems. For example, you have airframe systems, avionic systems, and mission systems. Okay, each airframe system, for example, if you see, a good example is actually a documentary on manufacturing of Airbus A380 in YouTube, or in Natural Geography, or it is also known as Engineering Connections, where you can actually see a wing which is being manufactured in Germany, which is a part of airframe systems, and a fuselage which is being manufactured in Belgium, and the other subsystems like airframe subsystems like empennage, the tail wing, and the vertical stabilizer being manufactured in Spain. But all these three are actually being assembled at Toulouse in France. Do you get me? So the figure that you see here is actually meaning that. So we have an individual subsystem which has airframe, avionics, and mission systems. So airframe is actually being manufactured into another subsystems, whereas you'll be having wing, fuselage, empennage in the sense like the end tail in part of the aircraft, which is known as empennage. That means you have horizontal stabilizers and vertical stabilizers. All these three are actually being put to safety regulations. Okay, and where you have avionic system is nothing but not only wires. Okay, you have everything is which is arranged into a jig, and these has to be put in exact form inside an aircraft. So avionics subsystem also has different kind of subsystems where there are different teams that work on each of the subsystem, and they actually put forth an assembled product which is avionic system. But avionic system, it cannot work itself. What is the use? If you are doing only avionic system, it has nothing. It has no more use. So what you do is you put it into an aircraft, which is the major system. So avionic system becomes an individual system of an aircraft. Similarly, you will be having mission systems. But you can see that, someone might ask, sir, why systems A and B are in blue and green, whereas C is in red? C is in red because it is the one where we actually see the influence of external parameters. For example, here you are having safety. Safety is one of the major concerns in aircraft design, because you are in a pressurized cabin at 30,000 feet. So you must ensure safety, right? So safety is one of the major parameters that will influence a performance of any subsystem. For example, if you have an engine failure, how will the system cope up an engine's failure? So these are actually systems that are being tested to real world, as far as we know, real world conditions where you have loss of thrust or loss of fuel leak, those kind of subsystems, where they are already tested and then integrated into a second level subsystem. So the name itself says you have individual system in part A, which are all the part of an aircraft, and you have integrated functions or integrated systems, which are all part of each individual system. So each individual system and integrated system has actually cross-functional characteristics. These cross-functional characteristics are nothing but you have human interface management, where one person might say, sir, I don't want this one because this one is not working with this kind of combination, I need other one. So there is what you have, a lot of editing, a lot of last minute changes. When I mean to say, it is not literally last minute changes, but it is just you have more factors that influence. Do you get me? So this is nothing but a lively example of hierarchical system. So going further, you must see what is generic form of a system. So generic form of a system, I think it is better to see for us in the next class. And I thank you. For the next topic, we'll be seeing in the next class, which is nothing but generic subsystems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.